Welcome everyone. Are you excited about AI? Everyone interested? Who is technical here? Technical engineers, software engineers, developers, something? Yeah? Who is working with AI already? Machine learning, natural language processing, something? Computer vision? Yeah? Who is interested from a business perspective in AI? Okay, that seems this will be a huge future, right? Who is interested in some, in the consequences and the impact that AI will have? Okay, that's the majority. So we have chosen the right panel, right? The right topic. So basically, we sat down with Boris a couple of weeks back, and we're discussing about where the developments of AI are today and where they're going in the future. And then we said, you know what? Why don't we, create a panel at the Next Web this year and invite some, very interesting people that are, working in that field from any kind of aspect, whether from its, applications, from its, societal implications, and also from a science perspective where it can go. So let me introduce briefly my guests today, and please give them a warm welcome and a warm applause afterwards, right? So, my first one is Nell Watson. Thanks for being here. Nell is a futurist and engineer, and she is founder of a computer vision company called Poicon, and also an associate at Singularity's faculty for AI and robotics. And she's deep into finding out answers on what happens when artificial intelligence exceeds actually human intelligence and other implications on our, humanity. So, warm welcome for her, please. Then Ronald, welcome you as well. Ronald applies deep learning technology in the Observe project at the Vrije Universiteit in Amsterdam at the VU. And he has worked in the field of AI for his whole professional career and life. And he's more focusing on the symbolic AI like semantic web. So please give him a warm welcome as well. And last but definitely not least, from London, we have Daniel. And he provides AI-inspired solutions in AI to solve the hardest industry's problem with his company Sitalia. And he's also director at UCL's Business Analytics MSc, applying AI in solving business and social implications. So please give him a warm welcome. So now let's start with you. You think and publish a lot on the humans, on humans' values, on ethical behavior of machines and more. You gave a talk earlier this morning. I hope you all saw that. And we had a couple of months ago, we had Microsoft's AI bot, Tay. And it went a little bit wild or rogue, right? Because it analyzed our communications and our social activities. What would you say is the important lesson of this, what we have been learning about out of it?
I'd certainly recommend that we don't attempt to create an ethical framework out of YouTube comments and tweets and stuff like that. I think one of the greatest lessons of the whole Tay debacle was that machines, like humans, like young humans, are like a sponge, right? And they suck up anything that they encounter. And with children, we are careful about what we introduce them to and the stimulus that we enable them to experience. We try to keep kids in a bubble where they will not encounter certain problematic or troublesome things, right? And I think that machines in certain ways also need to be firewalled to a degree, especially whilst they are still developing their major impressions about the world and how it works.
Ronald, you are working mainly in this symbolic AI set, but I also know that you have been very excited about the non-symbolic one, so the deep learning aspect of it, and that encounters, making sense and analyzing of, a lot of information and, building something out of it. How does this, work in terms of what Nell said and what we learned about Microsoft's AI bot? How can we develop AI that makes sense, actually?
So, the deep learning, it's quite amazing what it is being achieved in the last five years. It's able to solve the most complicated problem for computers in the game, the Go. It managed to win from the world leader. It is now able to detect your face expressions, your emotions. So it can now do all kinds of things that were used to be difficult for computers. So computers usually are very good in calculating things and storing things. But now it's also able to do things that we humans thought was, yeah, okay, but that is human. Facial expressions, if somebody's angry or not. So in that, and the magic is that the deep learning networks, they are very similar to the brain. It's how the human brain works. And therefore, one might argue they are now starting to look so much like humans. Maybe it is good that because it works the same like the brain, so maybe also the ethical behavior, and we also have to protect them the same way we are protecting humans, because they are showing similar behavior and they also look similar, like the brain is very similar to a neural network.
Okay. Daniel, there's a psychology professor from New York that created a company called Geometric Intelligence, and I also know that you have also different views on how to, where deep learning methodologies can lead us. Can you give us a little bit more information on what can we achieve with deep learning, and how can we solve the world's hardest problems, in the future?
Sure. Like Ronald said, we're able to develop soon deep learning models that are able to mimic human level intelligence, but there's quite a lot of evidence to suggest that humans aren't that intelligent. So I'm interested in trying to bring together the worlds of...
Let's quote that, by the way.
The worlds of sub-symbolic AI and symbolic AI. So we are, as biological things, very good at recognizing objects, recognizing things. We're not very good at solving problems. We're not very good at planning. And I'm interested in how we can bridge these two worlds, feed in what we can do and what we can get deep learning to do into hard AI or symbolic AI that can actually solve big, hard problems that we can't.
So, the statement out of this kind of question round was that humans can't really solve hard problems, right? But when we think about the personality of machines, when we're humans, we tend to generalize. Humans tend to interact and imitate other humans and other people. That's why we both are sitting nearly kind of similar in a way, right? But what role does personality play in the game of intelligent machines? Do they actually need personality, or is it a good thing to infuse them some sort of personality?
I believe so. I believe that...
Why?
Because personality is a part of personhood, if you will, right? They have the same root, and for a good reason. And we expect a person to have individuality, right? And we have persons in the sense of corporations that aren't flesh and blood, and yet have in many ways the same rights as a human being. And if we didn't have rights for corporations that are like a human being, the world would not work in the way that it does. And so machines are going to be needing our recognition as persons if they are to engage in the world with agency, right? Being able to be responsible for the things that they do. To be able to be sued or prosecuted, right? Or to defend themselves from predation by other people or other corporate entities. So in order to help recognize personhood in non-humans, I think that personality certainly helps humans to generate those kinds of assumptions.
Okay. So, Ronald, the question related to that is, you mentioned to me at some point that you can envision intelligent machines becoming even a human's friend, right? A companion.
Yes.
So how come? How?
So you know the Tamagotchi and the Furby. They are.
Wait a second. Who knows the Tamagotchi here? Who had one? Okay, I got you.
So, what is the people get attached to those, and children, of course, they get attached to their dolls, but we grown-ups are starting to get attached to these to the Furby or the Tamagotchi. So, if I would be arrested on the, for some crime, then what happens to my Tamagotchi? It didn't get fed for a day. That will only now, we are at the beginning of that. So I think we will soon see little furry robots, which are so aware of the situation, recognize you like, oh, are you sad? Because it can do machine learning and see if you are sad. It knows your email. It can maybe understand the topics that you were working on. Like, how was your presentation today? Did it go well? So once that starts to happen and becomes very personal, then you also get so attached to it that you want to protect it. So already from a personal part, it is good to think about it. Like, how can we defend it? You cannot just take your car away, only if you are the tax administration and you didn't pay your tax. But maybe we have to make exceptions for property, which is so personal and intelligent that you just not simply can take it away. So I think we now are at this moment that these things start to happen.
David, Ronald mentioned that we want to protect the machine. What about the other way around? I mean, machines protecting us. When you think about there's questions out there, there is organizations out there like OpenAI, like the Machine Intelligence Research Institute in San Jose in California, that does, and Future of Life Institute, they do a lot about protecting, humanity, protecting our life, everything that we achieved. But it's when I asked the question at the beginning of the panel, most hands went up and said, do you have a business interest in applying artificial intelligence? So how does this relate to for example, to the developments of AI? Is it really for social good, or is it really for business? Who controls that? How can we protect ourselves?
That's a good question. I think that initially business are going to embrace AI because they realize that, again, humans are not good at doing certain things, and we will build, and we are building and have built tools and technologies that can solve problems better than humans. And now we're embarking on this technology that is called AGI, Artificial General Intelligence. Let's just clear up what intelligence actually is. The best definition of intelligence that I've ever found is goal-directed adaptive behavior. And as humans, we have a goal and we can adapt and we can behave to achieve our goals. And we make mistakes. We are cognitively biased. We're not very good at doing certain things. And we will build computers that are smarter than us and better than us. At the beginning, we will build computers that are stupid. So we will build robots and empower them and say, many of you will have heard this before, robot, we've given you a brain, we've given you a body. The first thing we want you to do is help eradicate cancer. And what does the robot do? It eradicates people, because that's the easiest way of eradicating cancer. So we're going to build machines that
Quote, please.
We're going to build machines that are going to be making stupid decisions, and at some point in the future we'll build machines that are actually better at making decisions than we are. And you're right, we need to probably put together some ethical framework, some committee or something to try and figure out what does that world look like and how do we control it.
Thanks. Nell, following up that answer, it seems like intelligence machines, at least these days, are always reflecting the values of their creators, of the people who developed it. Do you agree? And how can we change that? Or is that something that will change naturally?
Generally speaking,
that's what humans are good at, right?
Yeah. Form tends to follow function, and machines tend to manifest the intentions of their designers, right? And the worldview of their designers. I think it would be ideal if the set of values that machines could internalize, if you will, were a little more democratic. Or perhaps we could set the preferences of how exactly we want those machines to bring those values into the world.
But human democratic? Because we know all about democracy and how it's can be circumvented or something. So who controls that democracy then at the end of the day?
We can come together as a crowd and we can specify what we want to have in machines. And we can create things like ISO standards that say a machine should conform to these certain behavioral heuristics. It's also possible to use meta rules. So there are about 7 billion human beings in the world, And we all have different values. We all have different weights of how we put one thing more important than another, etc. And yet, by and large, we get along, right? There's a heck of a lot of conflicts in the world, but generally, actually, the world is a surprisingly peaceful place in many ways, because generally we all have our own goal-directed behaviors that we want to win at. And trade and peace are good ways of doing that. And so you and I might have a disagreement, but it doesn't mean that one of us can hit the other one over the head. Even when countries go to war and the finest young people of the generation go and spill their blood, there are still Geneva Conventions, right? There are still rules about conflict. So if we can find those meta rules and help to specify those, then I think that provides a sort of freedom of movement within which a machine would not step on the toes of a reasonable person. I'd like to find those.
Okay. Ronald, how can we find those? What's your take on that?
So what is interesting is we humans are able to project. So like from Kant, the philosopher, it's like you don't want to do to somebody else something that you don't want to have happening to you in the same conditions.
Categorical imperative.
Yeah. And that is very important. Why is that? Because you are able to put yourself in the position of the other. Like, what if I was you? And for robots, that will also be maybe a very good thing, like a basic ingredient that the robot is able to understand you, but maybe that requires that you are also able to look at the robot's perspective.
Yes.
So once we get the Tamagotchi or the Furbies who are very smart, they are kind of, you go to the shop and you get a box and you have your baby. I think we humans will be able to create psychopaths out of them. Or just very friendly, innocent beings.
Yes.
And one of the things is if you are able to understand the robot's situation, like, okay, I was kicking it all the time and it does something nice and then I kick it. And for example, it has pain sensors and it experiences kind of pain. Yeah, then you create an entity that is just then not very friendly. So it's not the designer of the robot, but it is our interaction with that entity that makes it good or bad. So as long as it is a kind of a generic box that has the ability to understand the other, so that has to be designed, it is up to the caretaker to mess it up or make it a nice being.
Right, so if our dog bites someone, we are responsible because we presumably have conditioned the dog to have that behavior, right?
Yeah.
Depending, right? I hope most of us have an insurance for that, right? So we tend to outsource the problem again, right, to another solution. But Daniel, you also mentioned your interest is in good AI, right? How do you determine good AI?
The question is, how do you determine good? That's the problem. I think even as a race, we still haven't agreed on what is good. You hear all of these companies now that are cropping up. They're saying, I'm building this company for good. But for every one of those companies, I can think of a counterexample that damages the world. And I'm not even sure if we are capable of understanding what is best for us. And that might be something for the AI to solve.
Last question round before I want to open this up also to questions from the audience. Nell, can we expect some kind of AI CEOs or AI presidents in the midterm, long-term future? So a machine kind of, being on top of helping us to rule our rule-based systems, societies, and economy? Is that something that we could think of or envision?
Yeah.
You're saying yes, yeah?
We should all watch, it's a recommendation, The Prisoner. Yeah. It's an old series from '67, I think. Mm-hmm. And there's also one machine in one episode being kind of the leader of the community. We are already now in that stage, for example, for missile defense. The missile defense system is partially automatic. So we're already trusting our defense for computers. We trust our tax administration, our democracy.
I don't trust the tax administration.
No, okay. But we as humanity, we kind of agreed that is okay. So in that sense, we are already trusting technology, giving away our autonomy to computer systems. So I don't see it so far away that maybe also decisions, strategical decisions, might become a task from a super smart Watson machine doing that for you.
Okay. So another question to the round. What's the next challenge that we can expect? You mentioned Go. We all know chess in 1997. Then it took nearly more than 20 years nearly later that we had Go. In the middle we had Jeopardy with Watson again. What's the next challenge? Is there something out there that we can expect that computers or machines are trained on to
Martial
beat the
arts.
human?
We can get computers right now to recognize objects, but if you ask Siri what's the weather like tomorrow, it can do weather tomorrow and come back with an answer. But if you said to Siri, I'm in Amsterdam this week, I'm going to be walking around, I'm going to stay at this hotel, I like Italian food, and I want to see as many sights as possible. You ask that question, Siri, and it's not going to be able to solve it. It's not good at solving these types of problems. So I think the next frontier will be how do we get AI to help us solve these more difficult problems rather than just doing a pattern search.
Okay. Now, one last one for you. You're an engineer. You work with Singularity, but also in your own startup. Would you rather learn a new skill on your own, or train a system that could do this for you? It's like a language or a specific physical capability or another cognitive ability. Would you rather train one or?
It's a very interesting question because in many ways we have root on our own Turing complete, very powerful machine in a sense, right? And we can recursively self-improve to a degree if we wish to. And we can use that to help condition ourselves. We can, make sure that we have good habits and don't fall into bad ones and stuff like that. But we are limited in our faculties, and we are limited in the amount that we can reproduce behaviors. And one of the wonderful things about machine intelligence is that we can create a system that is capable of spawning 1 million entities that can then go and do something similar. So instead of myself learning Chinese, I can teach it to a machine, and the machine can then teach others, whether other machines or other people. I think that's one of the most powerful and beautiful things about machine intelligence, the sheer scalability of it beyond the 6 pounds of blancmange within one's own skull.
That's a great closing for us as a panel for my questions, because that leads perfectly, it ties into the result that you got of the question, is the business interest is the biggest interest of the audience here. So are there any questions from the audience? We have time for, let's say, 2 questions roughly. So yeah, first one is always. Yeah, hi. Can we have just a second, so that the audience in the back can also hear it. Just your name and...
Hi, Dominic Crozer, Crad Mobile. So as you mentioned, most people are interested from a business perspective. For those that are maybe not as familiar as the panel with regards to AI, what advice can you give us business people around how we can start testing and implementing AI within our own organisations? And I know it's different, but I'm sure there's a certain process that we should be going through to start the internal learning journey.
Yeah, I can help. So if you think that the process of building an AI is acquiring data, extracting insights from data to build a model, and then making decisions. And at the moment, most BI tools, business intelligence tools, which I think is an oxymoron, get data and then show a human some graphs, some pictures. And the human has to then interpret those graphs, build the model, and then typically the human makes decisions. So this is kind of where we're at, is the computer giving us some pictures, some graphs. But if you want to build real AI, then you have to have the computer to make the decisions for you and learn and adapt as it's making those decisions. So it makes decisions, it changes the world's changing around it, and that gets fed back in as data, and the model adapts. Does this make sense? So you need to connect these dots, and at the moment it's stopping at the insights level.
Great. One quick yes and no question from the audience.
Is it possible
yes
just
no?
to answer also on that?
Then no quick and no question anymore. Quick one.
So you have to be able to predict, analyze what kind of problem you have as a company. So many things are prediction problems. So looking in the future, what's going to happen? So for example, the energy market is a very good example. In America now, deep learning algorithms are able to predict the energy consumption of the next day. And these graphs are very complicated. But it was just learning by analyzing all kinds of things. People cannot even see in the network why some decisions are being made, but it is able to project for the next day the power consumption graph. So that is prediction for business is very important. So if it is a prediction task, we are already very close to at least knowing how to approach it.